Hello viewers, in today's class we are going to discuss one important and interesting problem from definite integrals, right? And here we'll solve this integral using the properties of definite integrals, right? So here the integral is given as we have to integrate from 1 to 11, and we have the integrand x minus 1 times x minus 2, x minus 3, x minus 4, and so on up to x minus 11, right? So here our integrand is a product of 11 factors, right? So here we have the 11 linear factors. So we have x minus 1 times x minus 2, x minus 3, and so on up to x minus 11, right? So this type of integral can be solved by using the properties of definite integrals. So let us call this integral as I, right? And here the property which we are going to use is this, that is, if we have the integral a to b f of x dx, then this integral can also be written as a to b and f of a plus b minus x dx, right? So this is a very important property in definite integrals to get the values of some typical integrals, right? So here what we have the integral a to b f of x dx, and in the next step what we do, we replace x by a plus b minus x, right? So this property simply says that x is replaced by a plus b, which is the sum of the lower limit and upper limit, and then we subtract x, right? Okay, so now here if we compare this integral with this one, then the value of a is 1, b is 11, and our function or integrand is x minus 1, x minus 2, and so on up to x minus 11, right? So now if we apply this property to this function, that is f of x, so now x is replaced by in this function a plus b minus x. So here we have a as 1 and b as 11, and here we have minus x, so this is 12 minus x, right? So now this integral I can be written as 1 to 11, and for each x we can now write 12 minus x, because x is now replaced by a plus b minus x, right? So now we have for this x we have 12 minus x, and here we have minus 1. Then we have for this x again we have 12 minus x, and this is minus 2, and up to 12 minus x minus 11 dx, right? Now let us simplify it. So we have 1 to 11, here we have 12 minus 1 is 11 minus x, here we have 10 minus x, up to we have 12 minus 11 is 1, 1 minus x dx, right? Now see, here we have 11 minus x, and here we have x minus 11. So what we will do, we'll take minus 1 common in each factor, and here the total number of factors are 11, right? So here we have 11 linear factors. So we'll take negative 1 common in each of these 11 factors. So what we will have, we have 1 to 11 and minus 1 raised to 11, and we have x minus 11, x minus 10, up to x minus 1 dx, right? So now this integral can be written as c minus 1 raised to 11 is minus 1, right? Because here the power is an odd number, right? So here we have minus 1 raised to 11 as minus 1. So here we have minus 1 to 11. Now let us rewrite this expression as x minus 1, right? So writing x minus 1 as the first factor, it means we reverse the order of factors here. So we have x minus 2, because here we'll have x minus 2, right? And then here we have the last factor, that is x minus 11, right? So this is this integral is our original integral I, right? So we have now minus I, right? So by using this property, we have obtained the equation I, because this is I. So here we have I is equal to minus I. So we can take minus I to this side. So we have I plus I equal to 0, which is 2I is equal to 0. So I is equal to 0, right? So viewers, by the application of this property, the value of this integral is equal to 0, right? So this is how we can use the properties of definite integrals to evaluate these type of problems.